Today, me and Christina will be discussing some of the mechanical properties of dental materials, which are proportional limit, yield strength, and ultimate strength. We have provided a fill-in-the-blank synopsis as you follow along with our discussion. Just as side information, as we may all be aware of, there are three states of matter, which are solid, liquid, and gas. Under the solid state, when a solid object is subjected to an external force, it undergoes change in size and shape, which is technically termed as deformation, or reaching its plastic state and will go back to its original form. The three mechanical properties of hardness go hand in hand with deformation and will be further discussed as we go in depth with this presentation. The first mechanical property that will be discussed today is proportional limit. It is defined as the greatest stress a structure of material can withstand or sustain without permanent deformation. When enough force is applied to one object or structure, it may not be able to recover from this force and the structure may become partially or permanently deformed. The object has reached its elasticity state. Elasticity state equals proportional limit. There are two terms associated with proportional limit: stress and strain. Stress is the deforming force, while strain is the apparent change in the shape of the solid object. In Figure 1, named Typical Stress-Strain Plot, the green line corresponds to the proportional limit. Increasing the stress is increasing the strain. In the initial portion of the curve, shown in the picture, from starting point to point A, the strain is linearly proportional to the stress. When the force exerted to the object is higher or greater than the value the object can withstand, strain increases, which exceeds the proportional limit. This results to strain to be no longer linearly proportional to the stress. The value of stress at point A will result to the maximum point of elasticity, which is the point called yield strength. As for an analogy, imagine the surface of a sponge. If you put pressure on it by pressing with your finger, the form of the sponge changes as you press your finger into it. This shows that the structure of the material is receiving the force coming from your finger, but it doesn't leave a permanent dent into it. It goes back to its original form as you release the pressure. By going back to its original form, it stays on its elasticity state, which is the proportional limit.
Yield strength. It means the point at which a material stops being elastic and becomes permanently plastic. In other words, a certain stress working on material produces a plastic deformation. Material yield strength. The magnitude of stress at which the transition happens is slightly higher than the proportional limit, but lower than ultimate strength. It indicates the point where the force applied to the material exceeds the proportional limit. As a consequence, permanent deformation of material takes place. As a restoration has a permanent deformation but no fracture, it's not serving the purpose anymore. It tends to a functional failure of a material. As shown in Figure 2, yield stress is used to determine the material is strong or weak. Irregularity along the straight line region of the stress versus strain plot. Hence, a different property, yield stress, is used in case where the proportional limit cannot be determined with sufficient accuracy. The image of the left side are brittle. It means material that undergo little or no plastic behavior. As well, a brittle material fractures at or near its proportional limit. Then, the image of the right side are ductile. Material that experience a large amount of permanent deformation.
As an analogy of yield strength, imagine stretching a rubber band and it reaches a certain point that will put it to the maximum elastic state, which we all know is yield strength. If you keep stretching the rubber band, it will go over the yield strength and go into plastic state, and it will result into splitting the rubber band into two. Another analogy is when you play with a slinky. Pulling the slinky changes the shape. Now it is stretched. However, if you release the slinky from being stretched, it returns to its original shape. Another scenario with playing with slinky, as it reaches its yield strength and go into the plastic state, it will cause permanent deformation to the slinky and won't go back to its original shape.
Ultimate strength is that the maximum amount of stress a material can withstand without failure in compression, tension, and shear. It is the height point on stress-strain plot, corresponds to necking in ductile material. Usually, it's different from fracture stress, which is the stress at the point of fracture. The yield stress is more significant than ultimate tension stress, since it can be used to predict when a material will begin to deform permanently. As shown in Figure 3, the ultimate stress is the highest point on stress-strain plot.
For the analogy of ultimate strength, we're going to use a small plastic cup together with a big heavy book to demonstrate the maximal amount of stress the plastic cup can withstand. By exerting the force coming from the book, the plastic cup was crushed, showing that the ultimate strength of the plastic cup was reached. Another analogy is thinking about something that reaches its peak. So if you're boiling water in a kettle, usually the kettle will whistle when the water reaches its boiling point, so that it represents the ultimate strength. And that ends our discussion regarding the mechanical properties of dental materials. To summarize everything, going back to Figure 1, we will demonstrate how proportional limit, yield strength, and ultimate strength relates. The green line, as you know, represents the proportional limit. As it reaches the elastic state, it goes up to the yield point, which is point A. As the force increases, it goes to a certain point where it reaches the ultimate strength, which is the maximal level where a material can withstand a force. After going over the ultimate strength, it will cause into breakage or failure point.